I
Hey, there it is, live.
think that's going. Okay. Yeah, so just a quick conversation about our recent move from Engineer to Google Cloud Platform. Just for anyone watching this, I'm Andrew, one of the co-founders of Resource Guru, and I'm talking to Kevin, who's one of our very talented engineers. And just wanted to really discuss the move that we made. So we've been with Engineered for around 4 years now, I think, and just recently took the plunge into moving from Engineered over to Google Cloud Platform. So Kev, I wondered if you could just give people watching this a quick overview of our tech stack and just explain some of the reasons why we originally chose to host on Engineered first of all, and then we can talk about Google Cloud Platform later.
Sure. Okay, so our basic tech stack that we've been running for the last 4 years it's a Ruby on Rails application at the core. It's a monolith, and we're using MySQL on the back end as a data store. We've brought in some new data stores and things over the years that we've been running it. So we've got Memcache in there, and we've got Redis in there as part of running our webhooks and our background queues. But yeah, in general, it's a standard Rails stack that we've been running for the last 4 years.
And what did we like about Engineered? I mean, what drew us to them in the first place? Was it just that they were the best cloud platform at the time for Rails, and possibly still are?
Yeah, at the time that we signed up with Engineered, so that's now 4 years ago, the space was pretty much dominated by Engineered. If you wanted something that had some decent performance VMs behind you and still have a platform as a service to run your applications. So you don't have the DevOps overhead of having to bring people in to maintain servers and so on, because Engineered does that for you. But it still gives you a very nice tool set to be able to deploy your Ruby application to their servers by just pointing to a GitHub repository or any Git repository, not necessarily GitHub. But it just takes a lot of that frustration and the manual intervention away from the day-to-day running of the application by using a standard platform that works for pretty much any Ruby application. Now, Engineered used Chef to handle custom configuration of their servers and gave us a cluster of virtual machines that ran on Amazon EC2. So we had basically the same kind of power that we would have had if we had just gone with raw EC2, but we could just take Engineered's configuration and run with it rather than having to go and build our own from scratch, which would have taken engineering time and distracted us from building a core product. And our priority at the time would have been to just get the product released and into customers' hands and get signups going. So we went with Engineered as a quick way of getting the application running in production with the kind of power that we would need for the user base that we foresaw coming, and with enough room for expansion as we went.
Right. And so we did that quite happily, reasonably happily, for about 4 years. And moving from one cloud provider to another is not something that people take lightly. It's quite a drastic step. So what was it that prompted us to have the need to move to Google Cloud Platform?
Well, we had been looking around at other cloud providers over the last few years, and that whole space has matured drastically since we started. Heroku is now hands down the easiest way of getting an application running on the web somewhere without having to go into setting up your own servers and things like that. And that's now a really mature stack. And we looked at that as a serious option for some time, but there was never really a compelling reason to go that route over what Engine Yard was already giving us. So why did we look at changing cloud providers? Well, in the first place, we grew to a point where we wanted to have a bit more control over our stack. We were looking at a stack other than Ruby exclusively. We've now got Go running in our stack. We've got other programming languages and other environments that we want to be able to bring in. We want to be able to bring in an extra service or an agent for a service like Datadog and not have to tinker with Engine Yard's chef recipes and hope that ours lines up with theirs. So we just grew to a point where we wanted to have more control over our stack. And Google Cloud Platform was just the one that we settled on in the end.
Okay.
Based on the merits of the platform, it just made sense for us.
And I know that Go was a reasonably big part of the reason behind the move. What is it about Go? What is it about Go that is better than Ruby and enables us to? Because I know we've had some pretty big performance gains from using Go. So what is it about the Go language that is so much better than Ruby at particular tasks?
Well, Go doesn't have the requirements of well, let me start at this point rather. Go compiles a binary executable that can run directly on the machine. It doesn't need to have an interpreter installed in order to run. So when we're building our Ruby code, we're actually deploying our raw source code to the server, and that source code then gets interpreted by the Ruby interpreter that's running on that server. With Go, the compiler will build a statically linked binary that contains everything that's needed for the application to run as a binary, and then you just execute that on the server. So there's far less runtime overhead when you're working with Go over Ruby. Now, that also gives you a lot of power at the going to a more technical level when you're able to control the machine at a far greater level of detail. You can control when memory gets copied and when you copying a reference to existing memory, for example, by using pointers. And by careful management of that, we're able to make massive performance gains over what we were able to do using Ruby. Right. The other part of it is also that Ruby with MRI Ruby has that global interp block, which prevents you from executing more than one operation at a time on a thread. You're basically working inside one thread with I/O being the non-blocking asynchronous operation. So any kind of computationally intensive task, Ruby is limited in its tool set to be able to scale that out and handle that. Where Go has the concept of Go routines, it's able to run in a multi-threaded environment safely, and we're able to leverage that parallelism to execute things, multiple things at the same time, so that we're able to reduce our overall response time for certain requests. Right,
and I know it's not just small gains we've had; it's absolutely enormous speed.
I mean, it's an orders of magnitude.
Yeah. Just talking about so Google Cloud Platform uses. So we're using containers, we're using Docker, we're using Kubernetes, and this all seems to be a bit of a revolution going on in cloud computing. And I know that Engine Yard have something called DIS or something that works with Docker or manages containers, and Amazon have their offering, and so did Google Cloud. So what is it that attracted you specifically to Google Cloud Platform, and how is this all different from the bad old days where people used to just upload their apps to a virtual machine somewhere? How are things changing?
So yeah, we're now working in a completely containered environment where our application runs in containers. And what that really means is a container is a very lightweight virtualization structure. So at the level of the containers, you're really looking at separate machines. Each container is really an isolated computer um, in a virtual machine sense. Now, in that when you start one up, it's effectively the same as having a cleanly booted VM, and when you shut one down, it's roughly the same idea. It's just that you're only working with the small layers that are changing between your base image and the image that has your code running in it every time. So they're very lightweight virtualization structures. And so we're using tools like Docker to build our containers. There are other options like Rocket that's coming on the Core OS project with the app container standards. We're using Docker and Kubernetes together, and that's really what attracted me to the Google Cloud Platform, and particularly container engine, is Kubernetes, which is effectively coming out of Google's. Google had that research paper about deploying containers at scale using their Borg platform internally. And Kubernetes is really the evolution of that internal tool that they've been using. So that is the real attraction to Google Cloud Platform. Because Kubernetes is open source, the Google Platform just gives us a very nice place to host it. But all they're really giving us is the hosted version of an open source product. So we could very easily pick up and drop this on another cloud without losing any of our configuration structure or anything like that.
Right.
And that was a very appealing reason to move to this specific platform. They're taking away the effort of managing the Kubernetes master and the private container registry, but all of that can be done ourselves if we want to, and we wouldn't lose anything.
Right.
Now, your question of how does it differ from the bad old days? Well, what you were able to do with AWS is build machine images. AWS, the AMI machine images, Amazon machine images, could be something that you could build out of your continuous integration environment, and that was an image that you could mount straight onto an Amazon VM, and it would just boot that image. And that worked very well for a lot of people. A lot of companies use that as a way of doing their operations. The gripe I always had with that is just the size of these images, that you're bundling your operating system, you're bundling dependencies, all of that together into this machine image that you could then move around. Where using containers, you're only shipping around the small layers, the differences between your base image and the image that you want to run inside the container. So that effectively just becomes our code that sits inside that layer. And then we can just build on, and we're using Debian Jessie as our base image. So we're just building on top of that image with the small chunk that is our code on top of that. And
lightweight.
Yeah, it's very lightweight. We're only moving around the things that need to move around. And the things that that can be shared, like when you're building up an operating system, it's sharing the operating system kernel with the base VM, which is also running Debian Jessie. It's lighter weight and it's more efficient. And it gives us a lot of the advantages that you would get by building machine images and deploying them onto separate VMs, except that we can do it on a far more granular scale now.
Right. Makes you wonder why we couldn't do this years ago. But anyway, we won't get into that now.
We can go into the history if we want.
That's for another day. Do you know what other companies and startups that you know of are starting to use containers and Kubernetes and this type of technology? Do you know of any? Or
well, I think the first example that we have to just point to is Google. And they've been running containers for over 10 years. They originally pioneered that tool, let me contain that for you, LMCTFI. which was a very rudimentary, long before Docker or anything was on the scene, way of taking some code and putting it inside a container. And there's the underlying technology of LXC. I mean, you would be able to run containers that way. So Google's the first example that I would look at there. And I think that at the scale that they're operating at, it just proves the technology is there, it works. But there are other companies, I'm just thinking off the top of my head, Etsy, I'm trying to think now.
Well, I know that Spotify is one of the big wins for Google. I don't know to what extent they're using containers. I would have thought they are.
They are.
Yeah.
I remember that they're actually featured on Docker's blog as well. If you go look at they've. In fact, Spotify built their own orchestration framework before Kubernetes was around. It's called Helios. That performed a similar function to Kubernetes, Docker Swarm. There are a few of these tools that kind of sit in that same area. And they built their own way of managing their containers over a cluster of servers as well.
Right.
But now I see that they are moving over to Google.
And in terms of so just going talk about the actual migration itself. How did we prepare for that migration, and how did things go in general? Were there any unexpected issues, or was it all plain sailing? I was there, so I kind of know.
Yeah. Well, we can let's talk through the narrative of it. Where we started with just preparation was setting up a staging environment. Let's just see if we can get Resource Guru running on Google Cloud Platform and what it looks like if we do it. So we spent some time researching and understanding Kubernetes and getting our containers set up. We had to make some code changes to our code that was reading out of configuration files and restructure that to work with environment variables. We had to make a few of those kinds of changes in general around the app. And that was just kind of preparation. And once we saw we had this working on Google Cloud Platform, we could then seriously say, yes, we want to make this a move. We want to move our production environment. And especially when we started seeing some of the numbers coming out of it, we saw some good performance gains. We saw our response times dropped. We saw using Kubernetes' health checking structure that we would have been able to mitigate some of the issues we've had in the past, just automatically using Kubernetes structures that wouldn't have even needed human intervention. So all in all, it was we did our homework first and we were pretty happy with what we saw. Then in preparation, then we had migrated one of our staging environments over from Engine Yard to Container Engine. That included moving your database, moving Redis, moving all of these things across. So we had an idea of how that would work. Obviously, no plan survives first contact with the enemy, so we had some issues on migration day. But all in all, it was we did our preparation that we were able to deal with them quite comfortably. So yeah, that was good. That was our preparation, really.
So the problem we had was loading MySQL database into their generation 1.
Yeah, the first generation. So we had a couple of fun issues to deal with on migration day. The first was something that we were doing before we took the site down or anything. We wanted to get the latest Redis backup, and we went on to Open Redis, got to the connection instructions from connecting outside of EC2, because you have to connect through a proxy that's got a limit of 10 gigabytes per month if you are connecting outside of EC2, which should have been plenty for us. And we then tried to open that connection and it just didn't connect. So we had to find another way around doing that. We ended up creating a VM on EC2, installing Redis on that, doing a master-slave replication of our production Redis so we could get a hold of a dump.rdb file. And then we could SCP that file across to our Google, to a VM that had a drive attached to it that would hold our database. So it was a bit of gymnastics around that. The other part was then migrating our database. So we downloaded we made a dump of our production MySQL database, copied that down, decrypted, and unzipped it. And then we had to get that onto the Google server again, which was a few gigs worth of upload to do. And that took some time. But then the thing that also slowed us down was trying to restore this onto the first generation database. And after, I think it was just under an hour, we figured, let's take a look at our other options here. So we fired up a second generation Google Cloud SQL VM to restore our database, and it was 5 minutes, I think.
Yeah, just suddenly picked up.
5 to 7 minutes, and our database was ready. So after waiting for an hour and a bit, we realized, well, we could have done this in 5 minutes.
The other problem we had was not being able to unzip our database on the server, which was a bit of a surprise.
Yeah, that was actually just unfamiliarity with tools.
Made the whole a whole lot longer.
Yeah, but in hindsight, that was really just a result of unfamiliarity with tools. So there's a gsutil command that you can copy a file down and copy it into a bucket from a VM on Google, and that goes at about 70 to 80 megabytes per second. So that would have been a much faster way of doing it had we known about that then.
Okay, well, you live and learn, and whoever watches this will also save themselves that pain of uploading a massive file.
Yeah.
Okay, and now that we're on Google's, let's call it GCP. Now that we're on GCP, they've got a whole range of services. It may not be as mature in terms of its offering to the public as AWS, which has been around for ages. But do you see us using any of the additional services that we're not currently using, and things evolving over time?
Well, let's just quickly look at what we are using, because we are using some things already that I don't think we initially would have expected we would have been using when we initially looked at the platform. So the basis we're using is a Google Computer Engine that provides us with VMs and an instance group that we can scale up and down fairly easily. We're using Google Cloud SQL, which is Google's managed MySQL provider. We've mentioned that part already. And then on top of that, we're using Container Engine to handle our container deploys. Those are really the basic services we're using. But we're also now heavily relying on the cloud logging facility, which comes from their Stackdriver project. That's basically replaced our external logging that we had before with Papertrail. We're now using just Google's cloud logging, and it's giving us all of the visibility we need into our logs. What else are we using internally? We're using the Google Storage Engine to provide us with persistent disks so that our Redis server gets persisted and so forth. Yeah, that's kind of just the gist of what we are using. We may at some point look at moving our Amazon S3 buckets over to Google. Google has got their own storage bucket solution that's very similar, just that we can drop our files into. So things like file uploads, image uploads, avatars, and things like that can be stored away there. And we can keep that on Google rather than splitting now across Amazon and Google. What else may we use? There may be a point that we switch to using their cloud DNS as well. They've got a very good DNS offering in there. I don't know how well it compares to something like Amazon's Route 53, but it's definitely an option.
Yeah.
Yeah, they've got some other tools in there, such as BigQuery. I don't think we're going to need those anytime soon, but when we do get to a point that we've got the volume of data needed to throw at a Hadoop cluster to analyze large volumes of data, Google's got all of the tools there that I think we'll reach for those long before we try and build our own.
Right. And I know that Google is actually quite a small player in this market. I was reading the other day that in terms of market share, Amazon's got 31%, Microsoft's got 9%, and I think Google only has 4%. So is that something that worries you, or do you just see that as, you know, growing massively over the next few years?
Google was definitely late to the market in this area. Amazon had a heck of a head start over everyone else, really. I think it was Amazon and Rackspace were the only guys who were really well known right at the beginning. You had the Linodes and that of the world as well. But Google already sitting at 4%. I mean, they're definitely growing, and they've had some major overhauls to their cloud platform offering over the last year. If I compare what I see there now versus what I saw there a year ago, they look like two completely different beasts.
Yeah.
We're seeing providers like Spotify moving over to Google. We're seeing some good cloud adoption of their services. And I think that the expertise that Google has from running Google.com, Gmail, Hangouts, all of these tools shines through far more than Amazon or Microsoft has.
Absolutely.
They're running at a scale that the other guys can't compare to, really.
Yeah.
Amazon maybe can compare to.
I hadn't thought of it, really, actually. That's very true. They run and have been running for years and years some very serious business apps. And they have, you know, thousands and thousands of business customers running their email, their docs, their G Drive, etc. So, yeah, you know, I mean, compared to Amazon, they're in a different ballpark.
Yeah. So, I mean, comparing the consumer market, they may be at 4% of the consumer market of the cloud. But if you add Google's services of Gmail and Google.com search and and Google Maps, all of that in there, I'm pretty sure that the pie looks slightly different, substantially different. And the expertise that comes out of them running these services so well all of these years shines through when you get to tools like Kubernetes and the entire container framework that they've put together around that, auto-scaling, all of that works exceptionally well. And like I say, you can really see their pedigree coming through.
Right. Okay, and just the last sort of topic, really, I think I get a couple of grey hairs every time we do something like move our entire platform. So when do you think the next time we might have to do this will be? Do you think container technology will be something that's around for this foreseeable future, or do you see anything else on the horizon that's coming up that may make us do this again sometime?
Well, I mean, you consider that container technology has already been around for about 10 years. Well, it's been for longer than 10 years. It's not a new technology that we're using here, but it's definitely a matured technology. But I'll get to the question of when we're going to move again in a bit. The thing that I think we'll stick to, and it's something that's been around since the early days of IBM mainframes, is virtualization. That's been the winner the whole way through, and that's what allowed IBM right in the early days to build new computers that had larger instruction sets, different CPUs, but still could run all of the old software that was built for their original machines by virtualizing. Now, virtualization comes all the way back from there. It's not something that we only picked up in the 2000s, although it gained a lot of popularity then. And what we're seeing with containers is just virtualization maturing and getting to a more granular level. A container is now able to share a kernel with other virtual machines that are completely separate from itself, which saves on the resource utilization of the machine. So is container technology the last? I certainly don't think it's the last.
I'm sure.
I'm certain that we're going to find something in the next few years and think, oh, that's pretty neat.
Yeah.
Well, we should use that. Look at those guys. I'm pretty sure we'll get to that point somewhere in the next few years, and whatever's next might already be in existence. It's just not popular yet. Or still needs maturity.
It's not next year.
I don't think it'll be in the next year. In fact, I'm pretty sure that what we're using here now has the momentum to keep going for the next few years, 3 to 5 years at least, before we see something else take over. I mean, remember the Docker project? We're using Docker for all of our containers. Docker's only been around for 3 years. It's still actually a fairly new project, although it's based on technology like LXC that's been around for quite a lot longer. But we'll continue to look for ways of virtualizing at a more granular level that lets us be more efficient about resources and allows us to have more flexibility with our code. One of the key drivers to Google Cloud Platform, we spoke about Go earlier, is it's not actually Go, it's polyglot. We want to be able to deploy more than one language and more than one code base to our servers and let everything work together. Now, when we were working with the engineered platform as a service, we were pretty much restricted to Ruby, where what attracts us to Container Engine is that you can put anything inside that container. You could put a Java app in that container. All it needs to do is expose a port and you can point to it. And if there are new tools that allow us to do that better, we'll probably look at adopting that in future.
Yeah. Yeah, well, all I know is we're on a much better, more robust, more flexible platform, and congrats to you and everybody else who made it happen. It was a very smooth migration and happened in a couple of hours on a Saturday, and it really, congrats, fantastic work.
Thanks. Yeah, it's been a lot of fun getting the environment moved over to this, and we're seeing so many gains already. Having some of the Go stuff in production that we're seeing as of today, drastic improvements in performance just by having better tools for the job that we're trying to do.
Yeah.
So all in all, it's been a great one.
Yeah. Well, fantastic work. Nice one, Kev.
Cool. Thanks, Andrew.
I know it's been about nearly 50 minutes, so we can wrap it up.
Cool.
All right. Thanks.
I think that's it then. Cool. Cheers,
Okay.
Andrew.
Cheers.